Ever get that, like, wave of panic when you've got a ton of programs running at once?
Yeah.
And your computer just freezes.
Oh, yeah.
It's like hitting a wall.
Yeah.
And it's a harsh reminder that as much as we love our elegant code, it all boils down to physical stuff happening inside our machines.
Right.
So today, we're diving deep into, well, the stuff that makes our code tick, memory management, specifically in PowerBASIC.
Okay.
Now, we've got a bunch of beginner-friendly tutorials we're going to be referencing for this deep dive.
Cool.
So no need to be a coding guru to follow along.
Right.
We'll unpack the essentials. But the first question that always pops into my mind is, what's actually happening to the data when we write a PowerBASIC program?
Well, it's interesting because, we throw around these terms like variables, data, but there's this whole system of organization behind them.
Right.
So imagine for a second a giant warehouse, but like incredibly organized.
Okay.
That's kind of like your computer's memory.
So I'm picturing rows of shelves.
Yeah.
Everything meticulously labeled.
Exactly. Each piece of data, each variable, needs its own little spot in this warehouse.
Makes sense. But data isn't physical boxes, right?
True, but the analogy helps. And just like in a well-run warehouse, there's a system to manage all this information.
Right. That's our memory manager.
Exactly. And this memory manager, it's got a tough job. It has to make sure multiple programs can run at the same time without messing each other up.
So it's like having different zones in the warehouse for different types of products.
Exactly. Keeping things compartmentalized. And the second big thing is efficiency. It needs to use your RAM, the quick access memory, and your hard drive, the long-term storage, in the smartest way possible.
Okay, and this is where it gets interesting, right? Because the tutorials mention these specific PowerBASIC commands for memory management.
Right.
And I'll admit, they always kind of make me nervous.
I understand in many, basic PowerBASIC applications, you might not even use these commands directly.
Right.
But even knowing that they exist, it's like, it gives you a peek behind the curtain.
Okay. So what are some of the key commands that, even the beginner should at least be aware of?
So two important ones are global mem and memory.
Okay.
Think of global mem as being responsible for like reserving those large sections in our warehouse.
Okay. So big picture stuff.
Exactly, the overall layout. Then you have memory. And this is more about the finer details like copying data, moving it around.
So if global mem is reserving the space, memory is doing the actual organizing within that space.
You got it. Now, there are others like peek and poke, but those are like specialty tools for more, advanced tasks.
Let's save those for a future deep dive then.
Exactly.
But even with these commands, it still feels kind of magical how PowerBASIC handles it all.
Oh, for sure. And to really appreciate the magic, we need to zoom in on what happens when you create even the simplest variable.
Okay.
Let's use that classic example from the tutorial. Creating a string variable called, say, strdata.
Right. So in the code, it's just one line. Super straightforward.
Yeah. But behind that one line, a lot's happening. PowerBASIC is setting up a whole system. It needs to store the actual data that strdata will hold, but also information about that data.
So it's like not just what's in the box, but also what kind of box it is, where it came from.
Yes. We need to know its name, strdata, its type, string, because it's going to hold text. And this is where things get really, really cool. PowerBASIC uses a system called pointers.
Pointers.
Yeah.
Okay. Those always kind of make my head spin a little.
I know. But think about it like this. Instead of storing the entire contents of strdata directly with its name and type, PowerBASIC uses a shortcut, a pointer. It's like an address system inside our warehouse.
So instead of moving this bulky box around, we're just saying, hey, it's over there on aisle 3, shelf 5.
Exactly. The pointer tells PowerBASIC exactly where to find the actual data in memory. Right. And this pointer system, it's one of the reasons PowerBASIC could manage memory so efficiently.
I never realized how much work is happening behind the scenes.
It's amazing, isn't it? But it gets even more impressive when we talk about dynamic data and how PowerBASIC handles those changes.
How they help PowerBASIC, keep track of everything in its memory.
Yeah, it's all about efficiency, right?
Totally. But then you mentioned dynamic data, and I'm like, wait a minute. What happens when the content of a variable changes?
Okay.
Like, let's say our strdata variable, instead of just, hello, now it's got to store a whole paragraph.
Right.
PowerBASIC freak out.
Not at all. That's where dynamic memory allocation comes in. And it's really quite fascinating. Remember how our pointer tells us where that hello data is stored?
Yeah, like our little treasure map to the data.
Exactly. So when you add more text to Stridata, PowerBasic first checks, is there enough room at that current location?
Okay.
If not, it doesn't try to cram it in.
Right.
It finds a new, bigger space in memory.
Like our warehouse manager finding a bigger shelf for a popular product.
Exactly.
Yeah.
But here's the key. Once it moves that data to the new location, it updates the pointer associated with Stridata.
Okay.
So now instead of pointing to the old hello, it points to this new, larger space with the whole paragraph.
So PowerBasic is basically keeping its internal address book totally up to date.
Yes. And all of this is happening automatically. You, as the programmer, you don't have to write any extra code to, manage this whole juggling act.
It's amazing. But even with the seamless magic, I gotta imagine things could get messy. Well, what happens to the old memory location where hello used to be?
Okay.
Does it just sit there empty?
That's a great question. And it brings us to memory deallocation.
Okay.
So when PowerBasic moves that data, it doesn't just abandon the old spot.
Right. That'd be such a waste.
Exactly. It marks that old location as available.
So it's like a self-cleaning warehouse,
I like that.
constantly tidying up.
But even with all this tidying up, there's a potential wrinkle. We call it memory fragmentation.
Fragmentation. Okay, now that sounds a little scary. What is that?
So back to our warehouse. Imagine over time, as data comes in, goes out, gets allocated, deallocated, we start to get these little pockets of empty space.
Like gaps between the boxes.
Exactly. And each gap might be too small to be useful on its own.
Right.
But you add up all those tiny gaps.
And suddenly you've got a lot of unusable space.
Exactly.
Ugh, it's like trying to find a parking spot in a nearly full lot. You know there are spaces, but none of them are big enough.
The perfect analogy. And just like, a savvy parking attendant might rearrange things to create a bigger space, operating systems have a solution. Defragmentation.
Defragmentation. So that's like hitting the reset button.
Kind of, yeah. It's a process that runs in the background. Its job is to tidy up memory, consolidating all those scattered free spaces into larger, more usable chunks.
So it's like the cleaning crew comes in overnight and just reorganizes the whole warehouse.
Precisely. And here's the amazing thing. This is happening all the time, behind the scenes, for every single program on your computer.
Wow. It's like this invisible orchestra working tirelessly.
It really is.
And I gotta say, this whole defragmentation thing is kind of blowing my mind.
It's a pretty amazing process when you think about it.
Yeah.
It really highlights what makes PowerBasic, what makes any programming language so user-friendly.
You mean the fact that we as programmers, we don't have to micromanage every single byte?
Exactly. All that complexity, the pointers, the allocation, the deallocation, it's all happening behind the scenes. So we can just focus on the bigger picture, designing algorithms, writing clean code.
It's like having a really good stage crew. Yeah. Right. Taking care of all the technical stuff so we can focus on the performance.
Love that analogy. And it speaks to the power of abstraction in programming. We don't need to know how a combustion engine works to drive, right?
Exactly.
Same way, we don't need to be memory management experts to write good code.
Right, right. Though I do wonder, are there any downsides to this level of, abstraction?
That's a really good point. And, while all this magic makes our lives easier, it's not without its costs. One trade-off is that it can sometimes make it harder to, pinpoint certain types of bugs.
Okay, yeah. Especially those weird memory leaks or fragmentation issues, right?
Exactly.
Like if our stage crew isn't communicating properly, it might take a while to figure out why the spotlight's not working.
Exactly. And in those cases, having that deeper understanding of memory management, it's really valuable. It lets you troubleshoot those tricky bugs, optimize your code for performance. Yeah.
It's like having that backstage pass, right?
Yeah.
You might not always need it.
Right.
But when you do, it's a lifesaver.
Absolutely. And that's the beauty of kind of peeling back the layers and learning about these concepts. It gives you a much deeper appreciation, I think, for the tools you use every day.
For sure. This deep dive has really opened my eyes to, the usually hidden world of PowerBasic memory management. It's amazing how much complexity there is in even the simplest code.
It's true. It's a testament to those who design these languages.
Yeah.
And remember, we've just scratched the surface. There's so much more to explore here, like garbage collection algorithms, memory mapping techniques.
Well, I'm ready for another deep dive soon. But for our listeners, if you're curious and want to learn more, check out the resources we've linked in the show notes. You might be surprised at what you find.
Happy coding, everyone.